طيب let me open board. نحن اليوم term 2 week 2 physics AMS. It's a bit late. I'm sorry. My fault والله. I was busy. I came late from school. بس مهم this is physics AMS. Yeah. هاي أول سؤال. For every action there's an equal in magnitude and opposite in direction. فمهم the way they word it is weird. There's supposed to be a reaction here. There's a reaction equal in magnitude and opposite in direction. هاي حفظ يعني. Just memorize it. Okay, here they want you to match أول شيء a box resting on an inclined plane. Uh, whenever you have, okay, let's look at this. نحن this week they asked a lot in the quiz about the three free body diagram. Okay, it's when you'd have, let's say this point is a box. Okay, this is a box. Okay, always you're gonna have the weight acting downwards and the normal force acting upwards. This is what we call normal. These are two forces that will always be there. Okay, this is a box, weight will be down, normal will be up. Okay, normal is the opposite of weight because you know every action has an opposite reaction. The reaction to the weight being pulled downwards is the normal force being pulled upwards. فمهم uh, that's when it's resting. Okay, let's say you had an inclined plane like this. Say this is an inclined plane and I have a black ball. Okay, at this instant, this is the ball. Okay, you'll have the weight acting downwards and the normal force, it will be like this time because you know the normal is always perpendicular because it has to be right angle. Okay, but they don't ask about that, but this is why the normal is like that, just in case somebody goes and says that why isn't it like this. No, no, it can't be like that, it has to be perpendicular. مهم, and obviously it's going to be falling downwards. Okay, so there's going to be a force like this. Yeah, and then there's always going to have friction. F. We call it small f. That's not a small f. Hey, that's not a small f again. Okay, friction. Small f. Small f stands for friction. Okay, because you know when a ball is rolling down, there's gonna be a force pulling it down, and obviously there's gonna be friction that's opposing the ball. Okay, this is yani these two are one of the most important parts for this week. ف let's solve this one. Here they're saying resting on an inclined plane. So if it's resting on inclined plane, like the one I drew here, there's gonna be the weight acting downwards. They said resting, not rolling. See, they said resting, not rolling. The weight is acting downwards. Since it's an inclined plane, the normal force will be like this, like I told you, or the other way around, of course. It can be the other way around. It could be like this. In this case, they want شو اسمه, the inclined plane to be to the right. Both are correct, by the way. And obviously, friction will be the opposite direction, like this. And this is correct because it has friction opposing it and it has the normal force that's like bent. Not every time, so this is correct. Not every time does the reaction of weight have to be the normal force. It just has to be a force in general. So when we have ropes, a lamp hanging from the ceiling, if it's hanging from the ceiling, you guys know whenever we have anything hanging or any ropes involved, it's tension force. Okay, so obviously we have, imagine this is the lamp, okay, and this is the ceiling over here. Okay, and this is the room. Let's say this is the room. This is the lamp over here. Let me put it in red. Okay, it's gonna be pulled down by the weight. Okay, and the force that's pulling it up is the tension. So whenever it's a rope being hung, the reaction to the weight will be tension, not the normal force. Normal force is whenever it's at rest on like a table or when it's on an inclined plane. فthat's the difference. واخر واحدة the last one, a ball kicked at an angle by a child. Okay, weight is always there. Imagine this is the grass pitch. I don't know why it's red, but obviously the weight is going to be pulling the ball down, and then this is the kick, the P. Okay, the kick P. I don't know why they called it P. They could have said like K or something. بس مهم This one is pretty simple. Question 3. Force equals something times acceleration, mass, أكيد, because you guys know, because we're going to use this formula now. F equals ma, mass. It's an easy question. Okay, a 1200 kilo car traveling at 25 meters per second in 5 seconds decelerates from 25 to 0 in 5 seconds. What is the magnitude of the force? Okay, we have mass given, and we have velocity, and we have time. Okay, and they want the force. You guys know we want the force. Force equals mass times acceleration. Okay, the mass given is 1200. Okay, with acceleration given, هي you don't know it. Yeah, like I was saying, uh, what did I say? Yeah. Acceleration we don't have it, but عندنا velocity we have time. You know that acceleration is velocity divided by time. So 25 divided by 5, so your acceleration is 5. So since let's go back to our equation, mass times acceleration times 5, بيطلع لك 6,000. Okay, what would be the net force acting on the car if it moves uniformly? Okay, again, force F equals ma. قلنا الماس is 1200. بدنا الاكسلريشن. بس you're saying if it moves uniformly. طيب, let's say you have a car. Okay, say this is somewhat of a car. Whatever this is, my fault. But this is a car, it's traveling, okay, at 60 kilometers per hour. Okay, if it's moving uniformly معناته the speed doesn't change. Okay, let's say the car continues and after 10 seconds it's still at 60 kilometers per hour. So there's no change in velocity, so the acceleration is 0. So whenever they say uniform moves uniformly, so acceleration equals 0. So here we say times 0, and obviously 1200 times 0 is 0. Okay, okay. هلا عندنا a box is pulled by a force F on a rough horizontal surface. The surface exerts on the box a force that can be broken down into two components: the friction F and the normal push N. Okay, without even looking at the choices, let's say this is the box they gave us, and it is the box B on the surface S and being pulled by force F. Okay, أول شيء you gotta draw the vertical, and obviously S is the horizontal. Okay, إذا هيدي ال F force F أكيد there's gonna be the friction force in the opposite direction. هيدي معروفة, we know this. What's gonna be pulling the box down? Obviously weight. And what's gonna be what's gonna be reacting to the weight? The normal force. So which one looks like this? Obviously it's gonna be this one here. You can tell me what's FSB? صراحة I don't know. To be honest, I don't know. But يعني SB يعني I think it's the force acted by the surface on the box. But I still don't get why. Because that's not important. Once you get this part, uh, you get the answer correct. هلا yeah, this one memorize it. What statements about a free body diagram? Free body diagram is the thing we've been drawing now, the one with the box and the arrows and whatever. It includes contact force, action at distance, because contact forces would be like the pull or the push. Action at distance could be like weight, because weight is at a distance. It is a simplified sketch. Okay, it's a simplified sketch. Okay, 7. I think it's also multiple choice. Yeah, which seems on a free body diagram are true. The objects on which the forces act can be drawn as a box. Magnitude of a force should be added next to the force if given. يعني here magnitude of a force should be added next to the force if given. يعني when you draw it and then you draw an arrow, you should draw like 20 newtons, but only if it's given. Okay, these are all in the book, by the way. It's one long paragraph talking about it. Uh, all given values should be added on FTP, FPD. Yeah, so any value you have should be added in your diagram. FPD is your diagram. Okay, here it's a puck sliding on a horizontal surface. Okay, what can be said about the motion of the puck? Okay, obviously it's going in a straight line, yeah? For any object to go in a straight line and not stop, it's going to be undergoing no friction. No friction, because if there was friction, it would slow down. Because you guys know Newton's first law, an object will stay in inertia, constant state of inertia, unless it's acted by like a force. So since it didn't stop, since it didn't slow down or change direction, that means there's no other force acting on it, so there's no friction. And in this case, this puck is, you guys know, the air hockey puck, air hockey puck, this one. This stuff, yeah. And like it slides because under the air hockey there's like air being blown up on the puck. There's air being blown on the puck, so like it just moves without friction. That's why this one has a zero net force, no net force because there's no friction. This is in the book. The examples in the book. It has no net force, obviously, because also it didn't slow down. If it didn't slow down, I mean, no net force is acting upon it. It didn't change direction, no net force is acting upon it. خلاص, it's a zero net force. Uh, showing no net force. Okay, when we say no net force, معناتها it doesn't change direction, it doesn't move, and it's balanced. Okay, if you have 10 up, 10 down, obviously the net force is zero, so the book or whatever object this is isn't gonna change direction, it's not gonna move, it's just gonna stay there. Okay, that's no net force. How about this one? Uh, Obviously, it doesn't have a zero net force. This one also again, it's obvious it doesn't have a zero net force. So this one you're gonna say, well, it is 30, 30, 30. Okay, so this 30 and this 30 cancels out. You're gonna be left with 30 to the right. So your net force will be 30 to the right. Okay. I'm not saying you're gonna ask. But see, some people they make these types of mistakes. Uh, the proportionality constant between F and A. Okay, this is just a formula. They just want mass. No, solve for mass. M equals. The original form is FMA. Take A to the other side. It's M equals F over A. Okay. A trolley and ticket timer set along a horizontal runway. A constant force F acts on the trolley. Acceleration is calculated. Experiment is repeated using the same constant force but with different masses. Okay. Whatever. This is all. Yep. You don't need to know this. But results of the experiment show that acceleration is inversely proportional to what? Okay. Whenever we say inversely proportional, one way to show it, like on a graph or like on paper, is solve for acceleration. Solve for A. احنا عندنا F is MA. For A would be F over M. Inversely proportional means the thing that's down. Okay? Acceleration is inversely proportional to M because M is in the denominator. For mass and acceleration are both inversely proportional. Okay. This question part A is easy, but part B it needs it's a bit tricky يعني. It's a bit long. نحن عندنا box weight 5 newtons coming down. Okay. At an inclined plane, speed is 0.2. The plane is inclined at 37 degrees with horizontal. Okay, so هن قالوا لنا 37 degrees with horizontal معناته this angle here is 37 degrees. Okay, they want what's the diagram of the block? Obviously, it's falling down. It has a weight downwards, and I told you the normal is always يعني it's not straight up on an inclined plane. It's to the side, and it's going to be opposed with friction F. Okay, obviously friction here is not going to be to the left. It's to the right because it's falling down, so the friction is going to be in the opposite direction. Okay. And what other choices? 1 second. Tension. T tension. ما خاص tension. I don't know why we have tension. Here the normal force it should be to the side and friction should be on the other side. For part A it's pretty self-explanatory. But see part B it's a bit tricky. Add to a new page. Hold on, let me get this. Uh, well, they gave us the mass is 5 newtons. Okay, the mass is 5 newtons. They gave us this angle is 37. Okay, and they gave us the speed. The speed is irrelevant صراحة. You don't really need it. So مهم. The magnitude of the friction forces on the block to the nearest integer is something newtons. Okay, and then you want force F equals ma. This is what you think you're gonna do, yeah? Because they gave me velocity. لا. Okay, من الآخر لا. They gave you this angle 37. Okay, and if you remember in the final, whenever we had like a force like this 12, okay, and they gave you like 40 here, 45 degrees, okay, and they told you split it into the horizontal component and the vertical component, okay, to find the horizontal, it was f uh, f1 times cosine of the angle, and for the vertical it was f1 times the sine of the angle. This was in the final, if you remember. Okay, مهم. Uh, that's the same thing we're going to do here. Since we don't have acceleration, we don't have time, so this كله على الفاضي, this formula كله على الفاضي. But they gave us the angle. Okay, let's look at it here. We have, uh, if this angle is 37, you know that this angle will be, since this is right, obviously, this angle will be 90 minus 37, which is 53. 53 degrees. So this is 53 degrees. So the angle you have is 53 degrees. So the angle you have is 53 degrees. To find the friction, which is like this. This is obviously horizontal. Horizontal. This is the horizontal. This is the x component of the force. Okay? We know to find fx, it's f1 times cosine of the angle. So let's do that. Fx in this case, or let's just say friction, small f, equals f1, which is the original force, 5 newtons, since that's the weight, times cosine 53. If I'm not wrong, you get 3.004 or 3.009 or whatever. But you get 3.0 whatever. Okay? And this is your answer, 3 to the nearest integer 3. And then now you're going to tell me the magnitude of the normal reaction. The normal reaction, what is it? The normal reaction, or the normal force, is the one that goes up. So obviously this is the vertical or the y component of the force. نحن بنعرف انه for the Fy you use the sine. So F1 times sine of the angle this time. Okay? For Fy in this case بتكون F1, which is 5, times the sine of the angle, sine 53, which, if I'm not wrong, is 4 point kaza 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 00 something or whatever. It's a long decimal. And when you round it, you get 4. I hope you understood this, صراحة. It's just know, for if whenever they want friction or horizontal force, you do F1 times cosine angle or alpha, and for when they want normal or the y, x is friction, normal, you use F1 times sine alpha. Okay, وكمان sometimes the angle, like here, it wasn't given to me, they gave me the other angle in the triangle, so you have to do 90 minus that angle. Okay, question 13. A block of mass 10 kilos, okay, a rough horizontal surface at initial speed of 10 meters per second. For the speed is 10 meters per second, or velocity is 10 meters per second. The block stops in 5 seconds. Use g is 10 meters per second squared. Okay, مهم أول شيء they're saying acceleration. Okay, acceleration is velocity over time. A velocity هي 10 meters per second. Okay, but it's going to a stop. Yeah, it's going to a stop. It's negative 10. Okay, divided by the time 5 seconds هي negative 2. The normal reaction on the block is something newtons. Okay, to find the normal reaction, remember that in your diagram you have weight downwards and you have normal reaction up. Okay, remember always that the normal reaction is equal to the weight. So if you have the weight, then obviously you can get the normal reaction. Or if you guys don't know, weight is equal to mg. Okay, mass times gravitational acceleration, which in this case is usually 9. Every time it's given, it's either 9.8 or 10, whatever. Okay, so W equals mass 10 times gravitational acceleration 10 equals 100. The magnitude of friction is something newtons. In this case, we do F equals mass times acceleration, because the mass was 10 kilograms and it slowed down. Remember, it was slowing down, so friction played a role in slowing it down. So 10 times the acceleration, which is negative 2, you get negative 20. طب وليد, why is the answer positive 20? A force can never be negative, so always put your answer in absolute value, which makes your answer positive. Okay? Okay, here they gave you a graph, 3 to the left, 5 to the right. They're saying a third force acts on the block. What is going to be the magnitude of this force and direction of this force if, and they gave us 3 cases. The block is stationary. Stationary, معناتها it's not moving. And if anything is not moving, معناتها total force, the net force is 0. Okay, هون our net force is 2 to the right. So you just need to find the opposite of 2 to the right, which is obviously 2 to the left. Why is it 2 to the right, Walid? Look, you have 5 to the right, 3 to the left, so 5 minus 3 is 2 to the right. Here is 2 to the right. فنحن to make it 0 in total, you have to put 2 to the left to cancel out that 2 to the right. So 2 to the left. Okay, and then here the block moves with a constant speed. Again, constant speed يعني inertia يعني net force again is equal 0. Same thing we did now. Since it's 2 to the right, the net force now, to cancel it out, 2 to the left. Then the block moves to the right with a net force of 8 newtons. نحن هلا our net force is 2 to the right. If you want the net force to be 8 newtons, you need to add to the right, يعني 8 minus 2, you need to add 6 more newtons to the right. In which situation is it possible that the block is stationary? Stationary يعني like the previous question, F and the net force is 0. So where is the net force 0? أكيد it's not this one. أكيد it's not this one. أكيد it's not this one. Obviously it's this one. The lines, the arrows, and the lines يعني they're equal. They're equal in length. Okay, they cancel out the left and the right. Uh, طيب هون يعطونا acceleration graph, acceleration time. Okay, it started from acceleration -4, went up to acceleration 4. The time at which the forces are balanced. Okay, forces are balanced يعني net force equals 0. If you have a net force of 0, always remember that if net force equals 0, then acceleration equals 0. You can prove this mathematically because F equals ma, and if you take m to the other side, it will be F over m. And if F is 0, the net force, so 0 over m, so obviously A equals 0. Because 0 divided by anything is 0. That's why A equals 0. Also, you can look at it if it's balanced. Remember the example of the car I gave you. Since it was moving uniformly, it wasn't changing, the forces were balanced, يعني the acceleration was 0 since the velocity was not changing. فالمهم we have to see where acceleration is 0. So if you go up to 0, it's at 2 seconds. Okay, here they gave us an object that has mass 0.2 kilograms. The object moves over a frictionless surface along the x-axis, so we're neglecting friction. So they're telling us to forget about friction. There's forces F1 and F2. Okay, F1 is 4 newtons and F2 is 2 newtons. Force F3, forget about F3. That's for part C. بس مهم, for now, let's look at F1 and F2. Let's look at part A. Part A, they gave us an object, a block. It's being acted upon by force F1 to the right, and they told us F1 is 4 newtons. يعني هون بتحط 4. اوكي بدنا الاكسلريشن F equals ma, فالاكسلريشن بتكون F over m. شو هي الفورس؟ الفورس هي 4 newtons والmass which is given 0.2. You divide them and you get 20. هون نفس الشيء F1 4 newtons, F2 2 newtons. You can't solve using two forces, so you have to find the net force. Whereas if you do 4 minus 2, you get 2 newtons to the right. Again, acceleration equals F over m. Force هي 2, اسم 0.2, you get 10. هلا part C. في ال F2 which is 2 newtons. هلا ال F3. Okay, ال F3 is directed at an angle 60 degrees below the horizontal. فهيدي here, if you continue this, هيدي 60 degrees. Okay, and has a magnitude of 1 newton. Okay, طيب. نحن we want the force, the x component of the force. We want this part of the force, right? To find the acceleration. How do we find that? If you remember the question with the inclined plane, it was a few questions back. To find the x component of the force, or the horizontal type of the horizontal part of the force, we do Fx, the horizontal force, equals F1, well in this case it's F3. F3, you always take the force multiplied by cosine of the angle. So in this case, F of the horizontal force would be F3, which is 1 newton, times cosine 60. Uh, yeah, and I don't have my calculator with me, I was using the Google calculator. فالمهم, when you do 1 times cosine 60, you get 0.5. Okay, so this force to the right is 0.5. Okay, because you can't use a force that's like bent down. You can't. You have to find the straight part, the horizontal part. فإذا عندك 2 هون و 0.5 هون أكيد the net force will be 1.5 to the left. Okay, we go back to our equation. A equals F over M. A equals the force, which is 1.5 divided by the mass 0.2, which is going to be 7.5. Okay, but you're going to tell me, Walid, why is the answer negative? Type, okay. Look, in this case, we ended up going to the right. In this case, we ended up going to the right. In this case, we ended up going to the left. وهنا قالوا لنا take the positive direction to be to the right. So أكيد the negative direction we're going to the left. Since we ended up going to the left, the answer will be minus 7.5. Okay, هنا أعطونا 10 newtons. This force is pushing these two blocks with 10 newtons. Okay, block A is 1 kilogram. وقالوا لنا block B is 4 kilogram. بدون acceleration. Acceleration here, force divided by mass, like we did earlier. Force is 10. Total mass is 5 kilograms, because 1 plus 4. بيطلع لك 2. Okay, the force AB acting on block B by block A is 8 newtons. Okay, they want the force, not the total force. The total force would be 10 newtons, صح؟ بس لا، نحن بدنا the one acting by A on B. Okay, you have to find it using F equals MA. نحن بنعرف إنه the mass of block B is 4 kilograms. والacceleration that we're using here is 2. So it's 8 newtons. And to prove this, by the way, if you want to see the force that's acting on A, same thing. F equals MA. The mass of A is 1 times 2, since acceleration is 2, is 2 newtons. Like this, our total force is 10 newtons, like they gave us in the question. This is just to check. You don't need to do this last part. But that's how you get 8 newtons. Okay, the total mass accelerated to the right by the force F is how many kilos? So how many kilos is this force F pulling? Just add these up. How many kilos is string 3 pulling? You just take these now, because you see string 3 is pulling only A, B, C. وبعدين the total mass accelerated to the right by string 1. For string 1 is only pulling A, which is 9 kilos. That's it. Okay. هون acceleration of A equals A. Yeah, here they're asking about the accelerations. A يعني acceleration. Okay, and accelerations. وهنا here they said it's a frictionless flow. أنا, if you remember, when I told you the ice hockey puck, the air hockey puck, the question with air hockey puck where it was floating on air, there was no friction. Since there was no friction, I told you it wouldn't slow down, okay, nor would it speed up. It was at inertia, so it was a constant state. So the acceleration in that case would be 0. If there's no friction, the net force is 0. Okay? Always, always, always. So the acceleration of all of them would be equal to each other. Here they're talking about the tension forces, the forces of each string. Obviously, the force that string 3 is pulling is going to be greater than the force that string 2 is pulling, and greater than the force that string 1 is pulling. Because string 3 is pulling all these, string 2 is pulling just these, and string 1 is just pulling this one. So obviously the force of string 3 is going to be greater than 2, and 2 is going to be greater than that of 1. Okay, this one, it's simple. I will show you have to get rid of these. Obviously, it's going to be, the net force is going to be something like an arrow like this, okay? So you're going to be left with these two, the red one, and let me just shade over this so you can know what I'm talking about. So you're going to be left with this now, okay? And obviously the one in between them is going to be like this. If you see, like this. That's it. Uh, if you have, I think it was clear, sir. Everything was clear. It's not that hard. Just the formulas. You have to understand the ways of solving. Thank you for watching. Honestly, appreciate the support on the channel, والله. Thank you, والله. I appreciate it. Inshallah, now in the weekend, I'll record for the physics periodic before Tuesday. Thank you guys. Thank you so much.